Hi everyone and welcome back. Today we're going to learn about surds. To understand surds, let's start with square numbers. Square numbers are special because when you square root them you get a whole number. But if we take the square root of numbers that aren't square numbers, we end up with surds. A surd is an expression that includes a square root that cannot be simplified into a whole number or a terminating decimal. Surds are useful because they let us write irrational numbers precisely. Since irrational numbers don't terminate and don't recur, they can't be written exactly in decimal form. But with surds, we can write them neatly. Let's begin with addition and subtraction. Here is an example. Think of it like algebra. If we let square root of 2 equal to a and square root of 3 equal to b, then we have a plus a plus a plus b plus b. Collect the like terms and we get 3a plus 2b. So in surds, square root of 2 plus square root of 2 plus square root of 2 equals to 3 lots of square root of 2's. And square root of 3 plus square root of 3 equals to 2 lots of square roots of 3. Here is another example. Again, treat it like algebra. 4 square root 3 plus square root 3 equals to 5 square roots of 3. 5 square root 10 minus 3 square root 10 equals to 2 square roots of 10. And don't forget the plus 2. The final answer is 5 square root 3 plus 2 square root 10 plus 2. Now it's your turn. Pause the video and try these questions. Then press play to check your answers. Here are the answers. You can pause again to check your answers. Now let's look at division. Square root of 10 divided by square root of 2 equals to square root of 10 divided by 2, which equals to square root of 5. Dividing surds by surds is straightforward, but be careful. Square root of 10 divided by 2 does not equal to square root of 5. 10 divided by square root of 2 does not equal to square root of 5. You cannot simply divide an integer by a surd like that. Here are some practice questions for you. Pause the video here and have a go. When you're done, press play to check your answers. Here are the answers. You can pause the video again to check your answers. Now let's multiply surds. Square root of 2 multiplied by square root of 3 equals to square root of 2 multiplied by 3, which equals to square root of 6. It also works in reverse. Square root of 15 equals to square root of 3 times by 5, which can then be split into square root of 3 times by square root of 5. This splitting process is useful when simplifying. Next example is 5 multiplied by square root of 2, which equals to 5 square root of 2. Just like in algebra, 5 times a equals to 5a. Square root of 3 multiplied by 2 equals to 2 square root 3. Just like in algebra, b multiplied by 2 equals to 2b. Here is a mixed example. 5 square root of 2 multiplied by 2 square root of 3. Here we multiply 5 by 2, which is 10. Then multiply square root of 2 by square root of 3, which gives us square root of 6. So the final answer is 10 square root 6. Now it's your turn. Pause the video here and have a go. When you're done, press play to check your answers. Here are the answers. You can pause again to check your answers before moving on. Some surds can be simplified by spotting square factors. Let's try and simplify square root of 50. Look for a square factor in 50. The square factor of 50 is 25. So we can write square root of 50 as square root of 25 multiplied by 2, which can then be split into square root of 25 and square root of 2. Square root of 25 is 5, so the simplified answer is 5 square root 2. Another example, square root of 300. Look for a square factor of 300. The square factor of 300 is 100. So we can write square root of 300 as square root of 100 multiplied by 3, which can then be split into square root of 100 and square root of 3. Square root of 100 equals 10, so the simplified answer is 10 square root 3. Here are some practice questions for you. Pause here and have a go, then check the answers. Here are the answers. 2 square root 2, 3 square root 3, and 7 square root of 10. Here are 14 questions designed to test the most common mistakes with surds. Pause the video here and give it a try, and then check your answers. Here are the answers. Pause here to check the answers, and let us know your score in the comments. So to recap, when multiplying or dividing surds, multiply or divide the numbers inside the roots. When adding or subtracting surds, treat them like algebra and collect like terms. Always keep an eye out for square factors when simplifying. Why are surds important in real life? Surds give us exact values for irrational numbers. Numbers like square root of 2 or square root of 3 don't have terminating or recurring decimals. So writing them as surds means we can use them precisely without rounding or approximation. This precision matters a lot in real life. For example, engineers and scientists often keep numbers in surd form to avoid rounding errors in long or complex calculations. Even a tiny inaccuracy can cause big problems later. Think about engineering and construction. Surds are used to ensure exact measurements when designing bridges, skyscrapers, and other structures, because accuracy means safety and stability. So next time you see a surd, remember it's not just abstract maths. It's a powerful tool used in science, engineering, and everyday life. If you found this video helpful, don't forget to like and subscribe for more GCSE maths tutorials. Thanks for watching, and I'll see you in the next lesson.